Yes, welcome, my dear students, for the lecture of Management of Information Systems. We are starting with chapter 2, that is the database in MIS. Yesterday, we discussed the overview of chapter 2, then the databases and their need in the MIS. Now, today we'll discuss in detail. Rather, uh, discussion, maybe the students of information technology, they may find that they are having they are having the uh, repetition or revision kind of thing, because these database technologies they have studied in their previous semesters. You had this subject called as database management systems. Yeah. So in this database management systems, we have studied what are the database. Generally, the database such as SQL or structured database we have discussed in our lower semesters. And today we are going to see or look at this database in the perspective of MIS. So how these database are there and uh, what were the approaches, this traditional approach as well as this database approach is there, and uh, how this database approach have made the impact on MIS. This is one part. Then from this database management systems, we have this data warehouse, we have data marts, and then we have these big data systems. So we are going to discuss this chronology of starting from what you can say traditional approach to maybe one of the complex systems that we are. Even database management systems are also complex. So that perspective is the part of this chapter 2. So yes, let us, my friends, go ahead with the discussion where this today's part will discuss the traditional database as well as the traditional approach as well as the DBMS as a part of MIS, and then and the coming lectures we can go ahead with the that part. So yes, let us start with this. Yeah. So this information systems that we are going to manage, that they are having various subsystems, and we yesterday we have seen the we, because we have taken one review of various types of information system in the last part of chapter 1. And again, when we started with this database yesterday, when we had this introduction, we had this revision or revisit to that discussion also, because I wanted to show you where the database approach is there, where this is how the database is very much relevant in information systems. And by the definition of information system, it is going to store, process, retrieve, manage the data, and generate information out of that. So yes, it is going to do majority of these operations. But let us see how these traditional approaches were there and how database are adding values to the MRs. Okay. So yes, we can see the decision support system, management information systems, and executive support systems. They have this database, and a well-designed and well-managed database is a extremely, or it is a key part of the MIs, any kind of MIs. Because now when we say now these are all distributed systems, maybe because of this company is present all over the world. So we are having various locations where a specific company works, and so these typically nowadays these databases are online or cloud based or even private clouds are there. So it is an integral part. We cannot work with an with an IS without the database. This is the thing. Okay, so this is a brief recap of hierarchy of data, starting from very I'll say that low level value or on the disk size of the data to this actual what you can say front end that we have as a file, or the developers that they work with the database, maybe developer or web admin. So at the very lower end, what we are having the root of the hierarchy, we start with the bit, how the data is stored. Data is stored as 0 and 1 on the disk, depending on what kind of storage you are having. maybe you are having the optical drive and DVD drive or kind of thing. So there the data is stored as optical, what you can say, bit. It is not technical. It is, there are ridges and grooves on this aluminum foil. Or if you are using this HDD hard disk drive, so it is having the magnetic interface and stores data on that. Now today's we are having these static storage devices, so they are having the semiconductor based storage. NVRAMs are there, who NVROMs who store the data. So technically, what is the lowest, what is unit of data storage or lowest hierarchy level is that bit. It can be 0 or it can be 1, and these bits come together to form bytes. Okay, so one bit is either 0 or 1, one single bit. So byte, it is a collection of 8 bits. Okay, so we are having byte, and this byte, kilobyte, megabyte, it goes on. These are the storage units. But now we are talking about the data hierarchy of data. So bit generate bytes, bytes generate the field, a course field, or a typical, what you can say, kind of student ID or course or data. These are all field. They are the attribute of a specific entity. So my name is, suppose, Dr. Vinay Bharati. So this my name is Vinay is one field. So that field is having VINAYK. These are the characters, and each character is stored as a collection of bytes. Okay, so one character now it is stored by one byte. So typically, if there is some called some number is there, some weight is there, floating point value, so it will have its different storage types. So hope I am audible, and you are having my voice clear with you. So if you have any problem, you can put it on the comment box, so that I, in between the lecture, I keep on monitoring the comment, so that if you have any doubt or if you have any issue, you can raise your hand, so that we can discuss the thing. Otherwise, you can put your whatever question in the comment, and as the lecture will end, we will discuss or I will address the thing. Okay, so yes, let us go ahead. We were discussing the records. Yeah, so these bits, it will generate a field, or I'll say attributes, and these attributes come together and they form the records. So one student, typical student record, you can find a student ID, course on which the student is enrolled, date and grade. Now all of you are familiar because you are part of this ERP system, and if you take the example, your record is in their ERP in typical format. We have your email ID, we have your phone, we have your parents contact detail, kind of thing. Then your progression throughout the all semesters, it is also there, so that your term test mark, your attendance records are all there. And now from this, they are all in the database, but here it is typical one semester course record. You can see here semester course. Then for fall 06, you can see this the date. We can now have this MIS as your we have this even semester, odd semester, or first of second half. So we have SH 2020, and what we will, what grades will be awarded to you, it will be. So these records, multiple student record, they generate files, and such, for a typical class of BIT, if all such files are combined, they generate a database. So when we go ahead with the design and generate, so this is the hierarchy from bit to what you can say, top level interpretation of the data, that is the database. So this is how the data is, what you can say, present in the system. Okay, let us go ahead. Yeah. So now, as a part of this subject delivery, we have to compare, or we have to understand these two approaches. One is traditional approach of database management, and second is the new approach, that is a digital approach or database approach of data management. So it is, and both the approach are for the computer based information system, CBIS. Okay, both the approaches don't, even before that, traditional approach could have been the files, the physical files, and they could be storing the papers. Okay, so recently I visited one Jilla Parishad school in uh, our native village, and I could see that because it is a school which is having very low number of students, and it is a government school. so resources are limited. But whatever resources are there, they are using it they efficiently. They may not, they have this online system on which they are putting the student record. Once they have all this record in the student files, which are the physical files, on a periodic basis they transfer it to the digital records. So yes, they are following both traditional approach as well as database approach. So sometimes this system coexist. Okay, sometimes, but many, what you can say, for where the records are too many, like in our college, even we have same thing, that we are having the some critical physical records also, maybe your admission document, and then for all the further records they are digitized, because we are having 8 semesters and around 2000 students are there minimum, and to manage such records it becomes difficult. So yes, so what I want to say is that we have these approaches. These approaches are, what you can say, depending on the need, time, and what you can say, what resources you have, we can follow. And obviously this database approach, they add how our today's our discussion target is that how they are going to add the value to our MIS. Okay, so traditional approach, we have separate data files. Data files you can see as, or you can perceive it as a typical Word file or OneNote file, or typical, what you can say, Notepad file kind of thing, where data is stored, records are stored. Okay, maybe they are entered from the physical file to this file. So these are the, this is the where we are not using any database management kind of software, we are managing it manually. And other approach where, what you can say, we are using a dedicated DBMS, database management software, to manage the data, where the whatever the data which is entered to the system, it is shared by multiple applications, multiple program, and there is a dedicated management uh, program is running on that. Okay, so these two approaches are there. This is, remember, they are very critical thing, traditional and database approach. Okay, so now here you can see a typical deployment of a traditional approach. Maybe you can think of this. This is quite. I'll say that maybe some people are still personally managing their personal record using this. Maybe some songs, you are having office documents, then you are having your personal documents, and you are using different programs for that thing. Okay, so this can be a very naive approach, or, but we are talking about a company which is using this, flat file approach or typical approach for storing. So here we can see there are different departments, where this manufacturing department is there, sales departments, human resource HRM, and finance and accounts departments are there. So there various users are there, and these are all, what you can say, independent subsystems are there, and they are having their own program for this manufacturing management, SCM, or supply chain, the sales marketing and supply chain management, recruitment, and, what you can say, payroll, that is human resource, and then overall finance management. So for maybe here they might be using the tally for finance and accounting. For human resources, they may be using simple storage system, simple file directory storage for their resumes and other things. Sales and marketing, again, they might be using Tally or other softwares. And for manufacturing, from design software such as CAD, CAM, to this supply chain management based, online system they might be having, and then they are having their dependence file, okay, which are part of that software. So independently they are going on, and these files, master file data elements, may be there, may not be there, depending on the type and nature of the argument or organization. Maybe they are storing all these files to the central servers, central storage, and accessing this file over the network. That is also possibility. But though they are using the network, and they are having, still they are managing this data files either individually or manually. Okay, so because of that, what happens that maybe certain records are common to choose. Like here I am having one employee which is working in this company. So this employee's record is here in HRM, as well as employee record is here in this payroll or finance and account system. So it may be happen that there is duplication of some fields, may not be directly filed, but fields, that is a possibility is there. Okay, again, even with sales and marketing and manufacturing, they work together, and they have to share many, what you can say, uh, types of files or data or attributes, and there will be duplication. So this is a typical system. Let us see what problem we face with the traditional database approach. So yes, these problems are displayed here. You can see that what problem we are going to, what you can say, discuss these problems in a bit depth. Okay, so yeah, we are having problems such as this data redundancy and inconsistency, program data dependence by the program or data dependence over the program. Means data dependency is there, maybe two programs using the same file. So we are going to discuss that in detail. Then we are having this poor data security, because now this file based system is there and manual kind of we are having this management of data. So we are having poor kind of security, data can be accessed. Okay, if you are having file level security, fine, but still it is not the perfect or at per level of security. And the last is that data sharing, as I discussed, that some department they might be, what you can say, having the sharing of this data or common records might be there, but because of this database approach, what is happening is that to share data amongst, maybe you will have to mail the file to the person, okay, or on the some storage device like USB drive or kind of, DVD drive, you have to keep the file and give. Again, this introduces the security risk in the your data transactions. So these are, and let us go and discuss them in bit detail. Okay. Yeah. So here you can see that the data redundancy problem is there, as so presence of duplicate data amongst the different data stores. This is the one thing. And because of this presence of duplicate data, there is one other problem arises, that is called as data inconsistency. What happens that if a person, as I discussed, that one person is on payroll and the person is part of this HRM and the person is part of this finance and account data also. So what happens that suppose at one point the person is getting promotion. So what happens that from this HRM record, the record has to be updated, and same time this record has to be updated in finance and account department also. If there is no dedicated process or protocol for that, what will happen? There will be designation change at the HRM department, and the finance and account department will not take care of that. Similarly, if there are multiple students, and if you have suppose progression of student from one semester to other, or some student is changing from one branch to other, or there is some correction, so at various department all corrections should be properly, what you can say, conveyed. If they are not conveyed, data becomes inconsistent. So if you query about the same person between for amongst the different department, you will get inconsistent data. This is the danger of the conventional file based approach. Other thing is that now, as I discussed initially with this approach, is that we start with this uh, various programs working for these subsystems. They are designed, maybe now when you are having this separate program designed by the separate developers, we have separate type of, representation for a typical entity. And because of that, what happens is that there is an inconsistency when the data is stored, represented, accessed, and again returned back. So this gives rise to the other problem, because if though the records are there and they are present in one system, if I want to read this record, there is a change in the coding. So this is the data redundancy and data inconsistency problem. Okay. Let us go ahead. Yeah. So other problems are program data dependence, as what you can say, one, what you can say, program is using, what you can say, for a typical mobile phone storage records, they are using uh, only mobile numbers, and one department is using country code, maybe then exchange code, and the full number format for the mobile as well as landline. So in order to make these two programs work together, they should follow the same, what you can say, format for the mobile number, or even if there is date of birth. So if DDMMYY should be commonly followed. If there is change, then the programs are, they will work with their own data, but they will not work with the other data. So data becomes tied to the program. In program, they are not interoperable. They cannot operate on the other records. It becomes a problem. Then this leads to the lack of flexibility because system becomes rigid. Then we discuss this security aspect. Okay, so if there is no dedicated database management system, only file system or password based systems are there, security may be compromised. And as I discussed, as the data is tied to specific program or specific process, the data sharing becomes difficult. Okay, you have to either manually share or you have to go through the, what you can say, server admin and specifically give the rights to the folder or file, and the person can approach the, what you can, specific data location and get the data. Okay, here is the, what you can say, the approach that is commonly used, that is the database approach. You might have, this you might have seen as a part of your, previous this database management system syllabus you might have studied. And here you have gone through this. So database management systems, they are dedicated programs, and these programs, they do the task of storage of the data, managing the data, and retrieving the data, and interfacing with the high level program for this process. So we are having this MIS where program is one part and database access, database management is other part. So this DBMS will handle the data backend for this, data backend for this whatever data you are operating on. So this, and believe me, because no, not believe me, it is uh, this data is one key part of our MIS, and the amount of data as the time is progressing, which is available to you within your organization as well as on the internet, it is exploding. We have seen that because of this, computer-based information system. One limitations that we have is that, what limitations we have? Information explosion or data explosion. So every day we are having data added to the central internet servers, as well as if you are talking about a closed organization, so we also have the same thing. We have the data which is generated within the organization and stored on its internal server. It is also cumulatively rising. So every day, for example, we are having our college and employee management system is there, as well as this ERP is there, where all of you are enrolled. So what happens that every day, whatever your attendance, these teachers are entering on the database, and every academic year, every semester, new subjects are created, and their attendance is logged. So, and this is there for lifetime. So even if you come after 20 years and say that, sir, what are my attendance record, it is there. So what is happening? Every day your records are added and they are going to be there, and we don't have this on-premise system, rather we are having this cloud-based system, and because of cloud-based system there is no dearth of storage. So that is going to lead to the availability of data throughout. And if we don't have dedicated database management system which is going to manage the things for us, this is going to create chaos. So that makes the presence and adoption of this database management system inevitable. So I hope that, my friends, you are getting this point, because you are all IT engineers. You will be working on this information system at some or other point of your life. And here you have to keep this aspect. Data is never going to be reduced. Yes, you will be working on that. You will be working on this data. You are going to process that. You are going to clean that and store it in a structured format. That is one thing. That's why we are studying these information systems. We have to do that. Otherwise, this is going to be the chaos situation. So this is very important. This is very important concept of management of information system. That is the inavailability. Sorry, inevitability of data management. We have to manage the data, because this is going to do, because from data we are going to generate the information we are going to consider for the, what you can say, input for a decision support system, executive support system, expert systems, management of information systems, various systems to take care of your future decisive strategy. Okay, so yes, let us go ahead. So yes, we were discussing this database. Okay, database approach to the data management. So yes, we are having data present in various files. These files contains records. Records have fields. Fields have bits are storage on the disk. Okay, this is what the data hierarchy we discussed. So yes, now these various users, they are having their, what you can say, in report generated from the data just we discussed whatever. Now this payroll system is there, inventory data is there, invoicing data, work from sales and marketing, and other data. These various systems, their data is stored on physical drive, and then this is the DBMS approach. We thought, or we discussed some time back about this conventional approach where file based. Here now files are there, data is stored in a file which is having the internal or its own database management system structured, and rather than accessing to a specific files, you will be accessing the records. This is very important change, my friend. This is very important change as compared to the previous, what you can say, scenario where in the previous approach we were directly dealing with the files, we were entering in the files, we were manipulating the files, we were sharing the files. But in this approach where database management system, we are going to do the same thing, but rather than with the files, we are going to do the same thing with the what, records. We are going to edit record, we are going to add record, we are going to delete record, we are going to manipulate records, and this we are going to do through this. I will say that there are these middlewares which are going to communicate with your DBMS and your application program. Okay, so these middlewares, they are maybe your database driver or database API interface. A number of things are possible. So job of programmer is to communicate with this middleware for the, what you can say, communication with the database. So handling security of the files, handling the location and storage of the files, handling retrieval of the files is taken care of by the DBMS. And as the users, we are concerned with the programs and its reports. As the developers, we are concerned with the database and its structure. So this brings, what you can say, this addresses very clearly the problems that we discussed. Okay, so slowly we'll discuss how it is going to address that as the time will progress. So yes, let us go ahead. So what is a DBMS? It is a software, it is a piece of software or software that permits an organization to centralize or centrally manage the data, okay, efficiently manage the data and provide access to the stored data by the application program. Providing access to the stored data by the application program. I told you this access to the data by application programs is done through this their database drivers. Okay, so you are having JDBC, ODBC. Then in case of Microsoft, you are having the ADO.NET driver as well. For this SQL Server, the ADO.NET is there. Then there are link drivers are there in case of this Microsoft. Then all major database, they will have this middleware layer which is going to interface between the programs and the database management system. Okay, and so that's why we just this end users, they don't have to worry about how the data is stored and managed. This is done. So that's why there are two views. This is another important concept. Again, we are revisiting that, this logical view of the database and physical view of the database. So it is the data logical view present the data where it is sensed by the application, like the table structure or ER model kind of thing. So this is the logical view, how the data is logically organized. Maybe student records, what a typical recording is, student name, roll number, address, date of birth, kind of thing. So logically they are present in a table. But this table might be present because so many student data is there on two separate files. And who is going to manage this thing? DBMS. It is not your problem. So this is the edge we are getting when we use the database management systems. So rather than going, I will just, yeah, we'll just discuss this thing, data redundancy, how database management system they are going to address the thing. So one problem that sorry, yeah. One problem that we discussed, that is the data redundancy and data inconsistency. So redundant, we had these separate departments, and they were following the separate file systems. But because of this database management approach, what DBMS approach, what is going to be there? There is one central repository or central data storage, and this data DBMS middleware or these drivers, they are going to communicate with the various program. So separate copy of the same data is not maintained. Yes, they are maintained by the DBMS for the DR purpose, disaster recovery purpose, but that is the internal management. That is not your lookout. How this DBMS is going to provide you with the DR. Idea is that various department, they don't maintain their own separate copy of the database which they are accessing. Yes, they might be having their own format. This is the application level requirement. That is, but by default, natively separate copy is not maintained. So it removes the data redundancy part. Second thing is that data inconsistency, because there is a central storage, central access to the database. All applications there, and this database they provide you with this ACID properties, atomicity, then consistency. Okay, then yeah, I said property. I just forgot that thing. But this consistency is the one part of this asset property. So that consistency, because of this one application and this database management system, they are communicating with the database for any change. It is the duty of the DBMS to maintain one updated copy of record to all the transactions, all the applications which are going to perform the transactions with the database. Okay, then what other problems that we discussed is this, yeah, program data dependence, lack of flexibility, poor security, and lack of data sharing and availability. So yes, now again we know that there is one common record for of the, what you can say, employees. So whatever programs you are going to be you are need the access of the database, they are going to communicate with the middleware of this DBMS. So they have, when programs have to be communicating with the database, they will have to go for the common format. Then flexibility is also there, because now this, once you know what data, what you can say, what is the data DTL and DML languages are using, we can communicate with, or with the use of specific drivers and APIs, any program can communicate with the database. And now then security is also maintained by DB admin. So disk level security is there, access management is there. So it gives rise to improved security. There are separate connection string and access credential for that. And using this thing, we can easily share. So all share the data amongst various application and user. You can simply create the users, give the access right to the specific database, and you can access the data. So that is the, what you can say, uh, I don't say magic, but uh, how the problems are addressed by the DBMS which are faced by the conventional systems. Okay, yes. So here you can see that there one common database having, what you can say, all the specific records of an employee, and depending on, what you can say, one department who wants the benefit view and other department who wants the payroll view, only that specific fields are provided by the central database to various applications. So this is how the applications are sharing the data, and they are giving you the flexibility. Okay, so various now advantages that this database management systems they provide. Now majority of the things already we have discussed. So I will share the notes with you where you can go through these things. Okay. So rather than disadvantage, I will say that there are issues. Okay, where complexity, obviously, because simple file systems, there was no software, you were manually doing. Here you will have to go for purchase. It involves the licensing cost. Okay, then these systems are complicated whether you have to work with the middleware layer database drivers. So accordingly the program will become complex, but it will also give you security, so we have to work with that. And more recover from failure, this is one thing where it is one aspect where if the database fails, then database, it is not that it is impossible. We have to then again, what you can say, insert the disk, then go for this database recovery, and this may, what you can say, introduce some time delay. But DBMS can very well recover from the failure because there are traditional DR mechanisms are there in the DBMS, which they can. So yes, which they use for, what you can say, security of your data as well as recoverability of your retrieval of your data. Yes, so these things you should consider and you should be having knowledge of this thing, but they are not the impediments when you have to choose the DBMS. That is the thing. Okay, so now we have discussed till now we have discussed the traditional system, its database management systems, and how these database management systems they are addressing the problems which are faced by the traditional systems. Now, next part is that data modeling. So again, this is the revisiting of the concept where we are having this in ER models are there data model, how this data as a student, as an individual, the student is, what you can say, modeled to store all this record in a typical database file. Okay, so that is there are data model. What is the data model? It is a diagram of entities and their relationship. So we have written this thing as ER model. Okay, and we understand what specific business problem and analyze the data so that we structure the information and deliver it to the solution. So this is one thing that we have seen is the ER model, then relational database model. So nowadays various softwares are available. These are software called DBMS, that is the Oracle, Oracle 18G, Oracle 15G. Like these are some application softwares, SQL. These are all structure based with IBM DB2, then Microsoft SQL Server, CBS database, Microsoft Access. This is one of the simpler database, relational database system for low, what you can say, volume application. And MySQL, this is one of the open source DBMS. Okay, so they actually provide you with various things. This may not be directly linked to that, and this is one key aspect. So today we'll discuss briefly this, and we'll stop because next lecture we'll start with this. Then there are the warehousing data marts that they will discuss, and then we'll go for the big data approach. So non-relational database. This is very important thing. Non-relational database. So, this relational database as a part of this ER model, you have discussed this thing at your previous semester. Now, I started with this. Yesterday, we discussed this data for a typical organization. It not only comes from this internal sources, but it comes as well as from the sources which are external to the organization. So what are these sources? These sources include the social network data, the customer feedbacks, customer blogs, and the more even tweets. So all these things, they directly or indirectly affecting or contributing for your products, your services. So we have to manage such kind of data also. Maybe again in your organization, there still, though you are using the database management systems, you might be having separate format for this information or this data representation. So again, what I want to say is that data coming from various sources and data coming from various types. So to address, and again, it is not that data is always stored. Sometimes the data is coming in real time as stream of data, like YouTube videos, like Twitter tweets. So all these things, all this type of data, if we want to process as a part of our business, what you can say, dealings, then this needs a specific kind of database called as NoSQL database. NoSQL database. They are coming in category where the data, they this kind of database, they have schema, but the schema is not fixed. And nowadays these databases are quite popular. For example, your Facebook is using one of the database called as Cassandra. It is a column family store database. So this is just an example. Detailing we'll see later on, because whatever information that as a person you are uploading on Facebook may not be all fields will be present in other person information. So every person is uploading separate number of fields, and separate data, separate type of data is available for a specific individual. And to address such kind of situation, this NoSQL database, they are very much helpful. So today we'll stop here. I thank all of you for attending this lecture. If you have any doubt, either you can message me on my personal number, or you can put your doubt on the comment box, so that I will address the thing. I will wait for a certain time. I'm waiting. And otherwise, we'll conclude this lecture. Tomorrow we'll start with this non-relational databases, and then we'll continue the discussion to what are the data marts, what are the data warehousing, how data warehousing, data marts, they are part of the MIs, what is their roles. Then we'll go for this big data. What is big data? What is big data approach that I just, because this non-relational database, this NoSQL database, they are the enabler for the big data technologies. Okay, so I thank all of you for attending this lecture, being present here. Okay, thank you. Stay home, stay safe. Okay, have a good day. Bye.